Hello, welcome back. In the last video, we talked about even power functions. Specifically, we went over some key features, and we also talked about what happened when we changed our exponent or when we changed our coefficient. And so we're kind of just going to do the same thing here, but with odd power functions. So we have an example on the left. This is a cubic function, and it looks pretty similar to even power functions, except it almost looks like you took the left side and you flipped it down. And that's because when you cube a negative number, you get a negative number. So we end up having this kind of like squiggle. But anyway, let's go through some key features of this paired function. And then we'll talk about one more thing, and we'll be done with odd power functions. So our domain, same as always, we want to look at what can we plug in for x and get a valid output from. So there are never any problems with polynomials. So we're looking at negative infinity to infinity. Range, what do we actually get when we plug in our domain? And we can reference our graph here. We see that we are not limited anymore to 0 to infinity, like in the last example. Now we have y values all across from negative to positive. So our range is going to be negative infinity to infinity. Our next thing is going to be intercepts. It's the same as even power functions. It crosses at 0, 0. Cool. And then we also want to talk about where this function might be increasing. And so again, that was about looking at slope. It's going to be increasing where we have positive slope. So let's take a look here. I like to start on the right side. So if I go from 0 to infinity, I draw my lines, I see that my slopes are positive. And then let's look at the other side. Still going from left to right, that's important. So my slopes are still positive. Pretty cool. So looks like I am increasing from negative infinity to infinity. And if that's true, then we're not decreasing anywhere. So no decreasing. Now let's look at where it is positive and negative. In the last example, our function was always positive, but that's definitely not going to be the case here. We see that we are above the x-axis from 0 to infinity. So that's good. But then we're also going to be negative on the left half. So from negative infinity to 0, our function is below the x-axis. Okay. Next thing we want to talk about is concavity. So you'll remember that that was kind of like concave up like a cup, concave down like a frown. And then I also did an explanation with what's happening to the slopes. So if we look at this here, again, I'm going to kind of split this into halves, look at the negative side and the positive side. So when we start out with the positive side, I see that my slopes are getting more and more positive. Now, if I look at the negative side, it looks like my slopes are getting a little bit more negative. You know, they're kind of like flattening out. And remember, if we have that hill, that's concave down. If we have a cup, concave up. So it looks like we're going to be up from 0 to infinity. And then we'll be down from negative infinity to 0. So no longer concave up all the time. The last thing we want to look at is end behavior. Okay, so we want to talk about what happens when x goes to infinity and what happens when x goes to negative infinity. Sorry. It sounded like I was going to say a different variable, but I wasn't. Okay, so going to infinity, if we go this way, our y values are going up. Yay! So y goes to infinity. Now if we look at the other direction, if I move in this way, my y values are going to negative infinity. So that's a difference with even functions. The end behavior is a little bit different. So with even functions, my y values are always going to positive infinity. And then with odd functions, basically the end behavior is going to match up between the x and the y. If x goes to positive infinity, y goes to positive infinity. X goes to negative infinity, y goes to negative infinity. And those are all of our key features that we need to go over here. So the next thing we want to look at is what happens when we might put a negative sign in front of here if we get a negative k. And we looked at this in the last video, and you'll recall that we flipped over the x-axis. The reason that I'm talking about negative k again is because the symmetry of this graph, it kind of looks like it could flip over the y-axis if you put a negative sign out in front, but we have to keep in mind that that's not what's happening. So I can kind of show you sort of what this would normally look like, kind of like that, right? And so we didn't take that green graph and flip it across the y-axis. What we did was we flipped each kind of branch over the x-axis. So this branch went here, and this branch went here. So that's kind of an important distinction to make. And that does it for this video. So thank you for watching.